Welcome back students to Vedantu's NCERT Solutions for class 11 and 12. We are going to discuss the fourth questions from the D and F block elements. The question is, to what extent do the electronic configurations decide the stability of oxidation states in the first series of the transition elements? Illustrate your answers with example. First and foremost, we need to remember this half filled and completely filled orbitals are very stable. When it comes to the first series of transition elements, they have 3D orbital. Okay, if it's 3D5 and 3D10, the respective metal is going to be extremely stable. The metal ion is going to be extremely stable. So which are the elements, which are the metals that are in first series? So we have scandium, we have titanium, and then we have vanadium, chromium, we have manganese, we have iron, cobalt, nickel, copper, and then we have zinc. Okay, so I'll write the electronic configuration here. So argon followed by 3D1, 4s2. Here for titanium 3D2, so of course argon is there, 3D2, 4s2. And then we have vanadium 3D3 and 4s2, chromium 3D4, 4s1. Okay, so chromium is going to be half filled because it is more stable, 3D5 and 4s1. And then we have manganese where 3D5 and 4s2 is the electronic configuration. And which are the oxidation states that are exhibited by these respective elements? Let's see that. So this is about the first half of the elements. Okay, so let me write for iron as well, 3D6, 4s2, cobalt 3D7, 4s2, and nickel we have 3D8, 4s2, and then we have copper, so 3D10, 4s1. And for finally we have zinc, so which has electronic configuration, I'll write it here, zinc 3D10, 4s2. It's highly stable because it has completely filled orbital. So moving on with the oxidation state, scandium shows +3 oxidation because if it loses all the 3 electrons, 2 from 4s and 1 from 3d, it is going to attain the nearest noble gas configuration, which is argon. So scandium is not going to show +2 oxidation state, rather it is going to show +3 oxidation state. Titanium is going to show +2 oxidation state, +3 oxidation state as well as +4. So vanadium +2, +3, +4 as well as +5, and chromium is going to show +2, +3, +4, +5 as well as +6 oxidation state, and manganese +2 to +7, and iron again +2 to +6, cobalt +2 to +4. Okay, so the list goes on here. If you see the electronic configuration of all the metals here, what can we deduce? So the elements, we are considering the elements from the first half. Okay, the elements in the first half of the transition series, exhibit multiple oxidation states, oxidation states, and manganese Mn has maximum number of oxidation states, oxidation states varying from +2 to +7, and in the third question, we have discussed the stability of +2 oxidation state increases. So let's take the example of the same. The stability of +2 oxidation states increases with increase in the atomic number, increase in atomic number. So scandium's atomic number is 21. Okay. So why does this happen? This happens because this happens as more electrons are getting filled in the d orbital, Scandium does not show +2 oxidation state. OS means oxidation state. So it shows +2 oxidation. It does not show +2 oxidation state, but +3, because its electronic configuration is 3d1 4s2. It loses all these electrons. It loses all the electrons to attain the configuration of argon, which is a noble gas. Configuration of argon. Okay. So +3 oxidation state of scandium is extremely stable, is highly stable. And if we look at manganese, for manganese, +2 oxidation state is very stable, because why? Let's see here, +2 oxidation state manganese, so it is going to be half filled. So if we remove these 2 electrons from 4s orbital, it is going to be half filled. Okay, so it is stable because 3d is half filled. Titanium +4 and vanadium +5 are also very stable for the same reason. If we see the electronic configuration, let me go back. So titanium +4 and vanadium +5. See here, titanium +4, it is going to be attaining the argon configuration, and vanadium +5, it is going to be attaining the argon configuration. Okay, noble gas configuration means it's very, very stable. Okay, so what happens here? So for manganese 2+, it is very stable. +2 oxidation state is very stable, because after losing 2 electrons from 4s, manganese is attaining half filled electronic configuration. 3d5. So this is one of the examples. So what can we say? The electronic configuration decide the stability of oxidation states in the first series of the transition elements. We have taken the examples of scandium, we have taken the example of manganese as well.